Hello everyone. We are here to talk about how you can proactively monitor the health of your business using Amazon Lookout for Metrics. We are excited to announce this new service in preview that helps customers stay on top of the metrics they care about. My name is Ankita Verma and I lead product management for Amazon Lookout for Metrics. With me today, I have Brian Ecker, senior staff engineer at Nextroll, US's leading marketing technology company. In this presentation, I will talk about how accurate and timely anomaly detection is essential yet a challenging task for businesses today, and how Amazon Lookout for Metrics can help you close the gap. Brian will then walk us through how his team at Nextroll has benefited from the service as an early beta user and how they plan to leverage the service and its capabilities to solve critical problems for their businesses. Lastly, I will end the presentation with resources for you to get started. Let's start with what is anomaly detection and why should you care about it. Anomalies are unexpected changes in data which could indicate an underlying issue. Example, a sudden dip in revenue or a sudden spike in latency of your e-commerce website which is preventing your customers from making purchases online. It could also point to an untapped business opportunity. Example, a new sales category or a new potential customer base that wasn't under your radar. Both these scenarios require you as a business to respond immediately, as delays could cost millions of dollars, missed opportunities, or worse still, losing the loyalty and trust of your customers. Today, the problem of anomaly detection becomes even more critical and challenging as businesses produce more data than ever before via multiple sources like mobile, desktop, clickstream, etc. When I talk to customers about their data, most attest to having a business intelligence tool in place that creates reports, dashboards, and track their metrics or key performance indicators. However, they speak to major pain points or gaps that go unaddressed with these traditional monitoring tools. Now let's look at some of those gaps and pain points closely. First, scale. As we discussed in the previous slide, in today's world, businesses have millions of metrics to track across multiple data sources. Take digital ads for example. You want to track metrics like impressions, clicks, revenue, shopping cart metrics across campaign IDs, product categories, geographies, etc. And it's the same for any domain, be it retail, telecom, gaming. With traditional BI tools, managing data across disparate sources, creating dashboards, reports, alerts at this granular level is manual, requires maintenance, and unautomated tasks. I speak with a lot of customers who have reporting teams in place with dozens of people creating ad hoc multiple reports on demand. Third, alert fatigue and missed anomalies. This translates to inaccurate results. These traditional tools work by setting up rules. You set up a range, data points within the range is considered normal, and anything outside the range is an anomaly and you are alerted on those. If this range is too broad, you miss important alerts, and if it is too narrow, you end up receiving too many false alerts. These ranges are also static and don't change based on time of the day of the week, or seasons. They need to be manually updated frequently. So you miss important anomalies and receive too many false alarms, which wake someone up in the middle of the night when nothing important happened. So what ends up happening is that you lose trust in the tool and start ignoring these alerts altogether. Next, delay detection. These reports and dashboards are often generated end of hour, end of day, or end of week, when it's too late for you to act. And last but not the least, results are not actionable enough. So even when these results come, it doesn't answer the why. So developers, analysts, and business owners can spend weeks trying to identify the root cause of the anomaly, delaying meaningful action even further. Now let's talk about how we use anomaly detection at Amazon. Amazon is a global company with multiple businesses, and these businesses generate a lot of data. For example, Amazon.com sells millions of products across 180 plus countries. These product listings generate billions of clicks and impressions across several hundred million customers, multiple devices, software versions, and marketplaces. We see similar high data volumes within AWS services as well. For example, DynamoDB alone generates several hundred millions of metrics daily across thousands of hosts. Accurate anomaly detection to stay ahead of issues and deliver a good customer experience is a problem we have been solving since the very inception of Amazon. Now let's take a look at how anomaly detection evolved at Amazon as its business grew. We started with traditional rule-based approaches and dashboards as early as 1995. Around 2007, we started to incorporate machine learning techniques heavily for anomaly detection. ML allowed us to use all of our historical data and the broader context to learn our business cycle. For example, treating spikes in sales during holiday seasons, Black Fridays, or Prime Days, treating them as norms rather than anomalies. We continued to invest in machine learning and started incorporating deep learning techniques around 2015. We saw a step function improvement in our accuracy because models were now able to dynamically adapt to specific data characteristics like sparsity, irregularity, spikiness, among others, leading to fewer false alarms and reducing our time to resolution. As we introduced anomaly detection capabilities in QuickSight, CloudWatch, and Kinesis data analytics, we also learned that customers need to know the why in addition to the what. We have been working on root cause techniques to answer the why and make the anomaly results more actionable for the customers. In parallel, we continue to invent new ways to match the scale of data generated within Amazon. These experiences have led to several learnings on our end. Our biggest learning based on experiences with anomaly detection across multiple businesses within Amazon is that machine learning based techniques perform well but need to solve multiple complex problems. First, customer data is unique, and one single anomaly detection algorithm might not fit all data types and wide variety of metrics that your data has. So your metric set might require a hyper-customized treatment. Second, generating actionable results by learning relationships across customer metrics is critical to faster remediation, yet a very challenging problem to solve. Third, being able to dynamically adapt to changing business cycles and seasonal trends help reduce false alerts, resulting in improved accuracy. And finally, building accurate and effective anomaly detection requires ML expertise, which is expensive and challenging to set up. So today, we are very excited to announce Amazon Lookout for Metrics, a new fully managed machine learning service that takes all the learnings from anomaly detection at Amazon and puts it into the hands of everyday developers. The service will help you detect anomalies in virtually any time series metrics and determine their root cause with no ML expertise required. The service is available in preview now, and it's completely free to use during the preview period. Now let's dive deeper into Amazon Lookout for Metrics and the benefit it brings to the customers. Getting started with the service is easy. You can connect your data to the service via any supported data source. The service will continuously ingest your data automatically, use machine learning to learn the normal behavior of your data, and accurately detect data points that are outside the norm. It then creates an impact summary to help you diagnose the criticality and root cause of the anomalies quickly. Once anomalies are detected, you can investigate the results on the AWS console, consume them via our APIs, and create custom notifications and actions via an output channel of your choice. Amazon Lookout for Metrics also allows you to provide feedback and tune the system for continuous improvement. Now let's look at the benefits of the service in greater detail. First, ease of use. We are able to get data in from most sources that our customers care about. This includes popular AWS sources like Amazon S3, Amazon CloudWatch, RDS sources, and Redshift, and SaaS applications like Salesforce, Marketo, among others. It's easy to get your data in without upfront work. Once anomalies are detected, you can send alerts through multiple channels like Amazon SNS, Slack, Datadog, create a webhook channel, or automatically trigger predefined custom actions using AWS Lambda. Second, highly accurate anomaly detection. Amazon Lookout for Metric detects anomalies with high accuracy using the ML technology perfected at Amazon. The service uses ML to create models that are customized to your data characteristics, understand your business cycles and seasonal patterns. What that means is that you receive fewer false alarms and detect nuanced anomalies that are otherwise easy to miss. As you can see in this example, the service was able to quickly identify the two anomalies highlighted in red that deviated from your expected seasonal pattern. You would have missed these anomalies had you used traditional rule-based approaches if your static boundaries were too broad, as you can see with the dotted lines above. Third, actionable results at scale. Amazon Lookout for Metrics automatically identifies the likely causes of anomalies, group related anomalies together, and ranks them in the order of severity. It means you're able to prioritize, diagnose issues, or identify opportunities quickly without having to spend weeks root causing the issue with your BI or engineering team. In this example screenshot here, you can see that the service does an impact analysis, which tells you that for your anomaly in revenue, Android phones in US are the most impacted, and that's where you should focus your remediation efforts on. Finally, continuous improvement in accuracy. The service allows you to continuously adjust and improve the accuracy of your anomaly results. As you can see in the left image, you can provide feedback on detected anomalies, which the system is able to learn from in real time. You can also automatically adjust your sensitivity threshold in order to detect fewer or more anomalies. In the right image, for example, the customer changes their sensitivity from 75 to 85 in order to receive fewer alerts, or change it to 65 if they want to increase the number of alerts received. Amazon Lookout for Metrics is a general purpose anomaly detection service, so you can detect anomalies on any time series metrics. We have seen customers successfully test the service across the following use cases. Customer engagement metrics. These include metrics like login, clicks, views, purchases, screen time, bounce rates to ensure a seamless customer experience. Operational metrics. These include latency, CPU utilization, error rate, throughput, among others, that help you proactively mitigate service interruptions. Sales metrics. That includes number of leads, win rates, pipeline coverage, deal size to evaluate business growth opportunities. And marketing metrics, including traffic volume, revenue, churn to detect how marketing campaigns are performing. Next, I'll take you through a quick demo of the service. This is the landing page for Amazon Lookout for Metrics. We'll get started by creating a new anomaly detector. Provide it a name and a description. Notice you're asked to specify an interval, which is how frequently you want the service to detect anomalies in your data. I will select 1 hour interval for my use case. I hit create. My detector is successfully created. The next step is to add dataset to the detector. Again, I provide name, description. Now you specify the source of your data. Amazon Lookout for Metrics can automatically connect to 19 different sources. I'll choose Amazon S3 for this demo. You have two modes for running your detector. The backtest mode, which runs on historical data and detects anomalies in one go, and the continuous mode for anomaly detection on your live data continuously as they are generated. I'll select continuous mode for the demo. Now the service asks for the S3 location of one of my existing files. I already have my file uploaded in S3. I copied the URI. I paste it here. It will then automatically detect my probable folder structures in S3, pull new our data hourly as they arrive in this location, aggregate it, and run anomaly detection on it. You can optionally provide historical data for learning the past patterns and business cycles. If not, the model learns on the go as new data is generated. For this demo, I keep the option unchecked. I review the other configuration. They look fine. I hit next. My data has been successfully validated and I land on the mapping page. Lookout for Metrics automatically reads the columns or headings in your data and pre-populates this page. All you have to do is to choose and specify the measures you care about using these dropdowns. This is an e-commerce use case where we are looking to detect any abnormal changes in revenue. So I add revenue as one of my measures. I will also monitor number of views on my e-commerce website as I know that sudden changes in revenue are often caused by changes in views. Dimensions are the metadata or categories associated with my measure. My data has dimensions as platform. These are the platforms supported by my website like PC and mobile. And the other dimension is marketplace. These are marketplaces like US, UK, Germany, France, among others, which are top drivers of my revenue. So I'm monitoring two measures and two dimensions, but you can add more depending on your use case. I hit next. I review my configuration one final time, hit save and activate. This starts our learning process. During the learning process, Lookout observes your data points and creates appropriate machine learning models in the background. This might take some time depending on how much data you provided. I already have some results and will walk you through them now. In the first example, revenue saw a dip on November 24, 2023 AM GMT. The severity score here represents the severity of the detected anomaly. This is on a scale of 0 to 100. In this case, the score is 87, hence severe and needs your attention. The impact analysis here tells me that Germany and UK, where the marketplace is impacted with this dip, and mobile app and mobile web, where the platforms impacted during this dip. You also see the percentage contribution from these impacted dimensions. This already starts to steer my remediation effort in the right direction. I'm also notified that number of views saw a dip in the same marketplaces and the same platforms around the same time. Now the pieces of the puzzle begin to fit in as I learned that the dip in revenue was potentially caused due to dip in views on my e-commerce website. This is a sample dataset, but in real life, when our beta customer was alerted on these related anomalies in revenue and page views, they investigated and uncovered that the latest deployment in UK and Germany had led to a bug in their mobile platform. The bug was causing a timeout error during page load, preventing their end customers from browsing and making purchases on their website. They actioned immediately as they were notified to fix this issue, which brought both their metrics back to normal. You are also provided with a time series view of your metrics so that you can assess past trends and deep dive on your anomalies better. You can continuously tune and improve the accuracy of your models. There are two ways to do it. One is the human in the loop feedback mechanism, where you can tell the system if the anomaly is relevant or not, and the system incorporates your feedback in real time. You can also adjust your severity threshold. The severity determines the service determines the right default threshold based on the data, which is 70. So you can see everything with a score of 70 and above as an anomaly. You can dial the threshold up if you want to detect fewer anomalies. or dial it down if you want to detect more anomalies. You can play with it and figure out your sweet spot. For my data based on these results, I confirm that the default of 70 is the right threshold for me. The final step is to set up alerts so that I'm immediately notified when my data breaches my threshold. So I click Add Alerts. And provide the threshold, which is 70 for me, but you can choose it to any value you want. I select my output channel as SNS. Note there are 6 output channels available, including SNS, PagerDuty for notifications, and AWS Lambda for creating custom actions. I hit Add Alerts, and my alert is successfully created. This brings us to the end of the demo, and you have successfully set up your first detector using Amazon Lookout for Metrics. Now I would like to introduce you to Brian Ecker, who is the Senior Staff Engineer, Pixel and Data Collection at Nextroll. Brian will now talk more about the challenges they faced with anomaly detection on their ads platform and their journey with Amazon Lookout for Metrics as an early beta customer.
Thanks, Ankita, for that warm introduction. Nextroll is a marketing technology company delivering products that business-to-business and direct-to-consumer marketers use to expand their reach and grow their business. Our 3 business units are AdRoll, a growth marketing platform for direct-to-consumer marketers, Rollworks, an account-based platform for business-to-business marketers and sales teams, and Nextroll Platform Services, which is our platform as a service business for consumer and merchant marketplaces who want to integrate directly with our APIs and SDKs. At Nextroll, we're big believers in machine learning. We use it to power systems that analyze customer intent. We use it to improve our real-time bidding performance, and even to optimize our dynamic ad generation. We serve tens of thousands of businesses globally, and we operate in 6 AWS regions. We've been a long-time customer of AWS, and we use a number of their services to help power our platform. One of my favorite comments about our use of AWS tools comes from a chat our CTO, Valentino Valonghi, had with Amazon CTO, Werner Vogels. He said Amazon S3 is the closest thing AWS has to magic. We use it in so many interesting ways. It's way more than a simple data store. On the Pixel and Data Collection team, we're one of the primary sources of data and event intake for Nextroll's various services. Our customers install Pixel code on their websites so we can help them better understand and reach their customers. We handle almost 1 billion daily impressions and collect data for things like segmentation, customer intent, and conversion tracking. As you can imagine, collecting this data is mission critical. If the collection stops or is even partially interrupted, it can cause tremendous problems for the whole company's systems. We might miss a conversion event, we might lose branching decision that determines the best way to execute a campaign strategy. Basically, when we lose our data, our systems are flying blind. We need to be aware of unexpected data drops so we can respond quickly, but determining what a real drop is isn't as simple as it seems. For example, consider the problem of daily traffic patterns. We work with companies of different sizes worldwide. Each region sees its traffic ramp up in the morning, plateau during the day, and then dip in the evening. So you have to account for how those different time zones overlap, but the volume of traffic also varies by region. Now factor in changes in weekday or weekend traffic, and then account for seasonal variation in traffic like summer holidays or holiday shopping season. Is a drop in traffic just normal daily, regional, and seasonal variation, or is it a sign that something's broken? And if it is broken, who's it broken for? Was there a new browser automatically pushed to a fleet of mobile phones? Did a major operating system update just come out and something in our Pixel code is suddenly incompatible? It's just as important for us to quickly identify the specifics of the problem as it is to know we have a problem. We also do frequent code deployments. We do this to offer new features to our customers, to address new regulatory needs, and also to take advantage of new software development kits and frameworks in the browser. We do extensive testing, unit testing, behavioral testing, integration testing, but if a problem makes it into production, we need to be able to detect it quickly and to respond quickly. One of our current approaches to monitoring is to use Presto to query hourly metrics by user agent. That data is then exported to Datadog, where we've set up some alarms that fire if a drop in traffic exceeds certain limits. The alarms send messages to Slack and PagerDuty so the on-call engineer can respond. The problem here is the limits are manually maintained. Is that good enough? If a limit's too lax, it means we may miss a problem early on, and if a limit's too restrictive, we'll end up with too many alerts. The alarm will flap on and off, engineers will get alert fatigue and start ignoring it, and that's dangerous because they might miss a real alert when it happens. We'd like to take a smarter approach here, and we'd like to use something like machine learning to improve our monitoring. We'd like to change the limits dynamically based on things like regional and seasonal variation to cope with the browser market and the ever-changing device lifecycle. A system where we can train our monitors based on existing data collection logs so it can find real problems with future data collection. We'd like to do all this, but we only have so much bandwidth. So here's why we're excited about Amazon Lookout for Metrics. The use of machine learning and the feedback loop, the "was this alert helpful to you" control in the dashboard is incredibly powerful. We can use the anomaly detection intelligence that's already built in, and we can improve its performance, both by responding to these feedback prompts and by training it on new data sets. Another thing we're thrilled about is the triggers that the Lookout alarms can use. We already make extensive use of SNS for our reliable message passing in all of our systems. But here, being able to set up direct alerts through SNS to our NOC, to PagerDuty, and alert mailing lists through a single topic is huge. And the ability to run a Lambda function in response to an alarm provides tremendous opportunities. We could set up a function to prepare a report for the error itself, check source control for recent releases that might be related, and check our issue tracking system for recent deployments or planned network events. Basically, anything that can minimize the amount of work needed by the on-call engineer so they can find the issue quickly and they can fix the issue quickly. Now, we're still in early beta testing of the service, but we've already seen how easy Amazon Lookout for Metrics makes it to create a new monitor and supply a new data source. We're using S3 intake to read some customized log file data that we generated for Lookout from our open source Baker log file processing service. These logs contain timestamps, user agents, region info. An analysis of some initial data found an interesting and unexpected spike in traffic for a few different Android devices. Now, this wasn't the anomaly we were setting out to find, but it's interesting nonetheless because it gives us insight into an area that we might want our business intelligence team to do a deeper dive on to see if there's a potential market opportunity there. In Nextdoor, we're very excited about all the ways that Amazon Lookout for Metrics can help us. Ankita?
Thanks, Brian. Now I'll walk you through the next steps to get started with the service. Amazon Lookout for Metrics is now available in preview, and you can get started by accessing our developer guide and other onboarding resources. Again, the service is free to use during the preview period. You can engage with our solutions architect to brainstorm on your use cases and test the service with your own data. Certified partners can help you with the POCs and build integrations with current systems to productionize. We also organize immersion days, workshops, trainings, and certifications with practical education on ML. This brings us to the end of the session. Thank you everyone for tuning in. Please fill out our session survey that helps us improve our session for next year. Thanks.